Hello everyone, my name is Devaki, came from COI Warangal, studying in TTWREIS Society of Telangana State. Today I am going to introduce you a new topic, that is trigonometric functions. In geometry, we all know that many figures such as quadrilaterals, triangles and hexagons, pentagons and so on. All these figures are known as polygons with n sides. Let me consider n has sides. When we consider n is equals to 6, it is known as hexagon. When we consider n is equals to 5, it is known as pentagon. And when we consider n is equals to 3, it is known as triangle. Instead of using this triangle, we are using a new word, a Greek word, that is trigonon. The trigonometry is derived from 16th century using two words. They are trigonon, mean by triangle, and meteron, mean by measurement. So, the measurement of triangle is known as trigonometry. Coming to trigonometric functions, in this session we are going to learn about applications of trigonometry, introduction about trigonometry, graphing of sine functions, graphing of cosine functions, tangent functions, cotangent functions, cosecant functions and secant functions. I will tell you about what is trigonometry. As we know that trigonometry is a branch of mathematics which deals with the sides and angles of a triangle. It involves particularly in right angle triangles. Not only to measure the sides and angles of the triangle, it is used behind how sound and light waves are moved. Coming to trigonometric functions, it is the ratio of certain angle or certain part of a triangle is known as trigonometric functions. There are mainly three trigonometric functions. They are sine, cosine and tangent. These three are very useful to find out or to measure the heights or distances or everything. Before going to learn about this trigonometry, we should need to understand what is the applications of trigonometry in our day-to-day life. Coming to applications of trigonometry in our day-to-day life, it is used to find heights and distances in the architectures of the buildings, in the astronomy, in the geology, in the navigation purpose and in the oceanography. I will give you a brief explanation about each application, how we use these applications in our day-to-day life. Let me start with how trigonometry is used to find heights and distances. Trigonometry is used to find heights and distances or depths of anything easily by using two fundamentals. Do you know what are that fundamentals? Yes, that fundamentals are angle of elevation and angle of depression. I think you have a doubt about what is angle of elevation and what is angle of depression. So, to know about these angle of elevation and angle of depression, we can consider an example. That is, a man is standing on a mountain. The mountain is nearby a sea and a boat is travelling onto the ocean or the sea and a flight is moving upwards in the sky. So, the man who stand or the person who stand on the mountain will observe first the ship and next he will observe the aeroplane too. Then the angle made with the horizontal through his eyesight, when he raises his eye position to upwards, when he looks towards the aeroplane, is known as angle of elevation. And coming to angle of depression, when the person or the angle made with the horizontal, when the person raises his eye position towards the ship, is known as angle of depression. These, I think you have understood about what is angle of elevation and what is angle of depression. These angle of elevation and angle of depressions are two functions or two fundamentals which used to find heights, distances or depths. Not only to find these angles or sides or distances, it is used to find or to measure the height of the towers, like as Eiffel Tower or two towers, and the distance between two towers and everything. Now we move to the next application, that is trigonometry is used in the architectures of the buildings. Architects use this trigonometry to find or to design the exact building what they had in their mind. The architect use this trigonometry to design an exact building. So they use many kinds of applications such as sine, tangent, cotangent, all these applications. They apply all these things and they can design the exact building what they had in their mind. And now in this generation we are observing many shapes of buildings such as lotus shape, U-shaped buildings and lotus shaped buildings. So all these buildings or all these constructions are moving or going on by the help of this trigonometry. If they cannot use this trigonometry, they can build an exact building what they had in their mind. Not only these trigonometry is used to design or to construct a building, they use this trigonometry to calculate the slopes or roofs of anything easily by using this trigonometry. And coming to trigonometric applications in this architecture, they use to construct an exact building or they use to design a new building. According to history, these architecture or this trigonometry is used in architecture to design a new building. Like as if we take an example, that is Shah Jahan built an Taj Mahal for Mumtaz. This is the known example. This is an exact example for this for trigonometry used in this architecture. So not only to find out the architecture, not only to construct the buildings, it is also used in the astronomy purpose. Nowadays scientists or astronomers are using this trigonometry to find or to know about what are happening or what is happening in the sky or what is happening in the space. All these things will be known by using this trigonometry. Or the distances between two planets or the distances between two stars, distance between a planet and the sun, and the distance between Venus and the sun is also measured or calculated by using this trigonometry. And scientists or astronomers analyze everything what is happening in the space. They will analyze by using these trigonometric functions. So trigonometry plays an important or crucial role to find the distances or to find the radius of the earth and to find what is happening in the sky. These all things are done by using this trigonometry. Without using these all things, they cannot establish or they cannot discover new things. In this generation, peoples are likely to do the new buildings or to know about what is happening in the space and everything. So these all things are happening or these all things are done by using these trigonometric functions. It is used in geological purpose too. So trigonometry used by geologists to estimate or to analyze the slopability. What is the use of to estimate or to analyze the slopability? You have a doubt about this? I think so. So these geologists use these trigonometric functions to know about the slopabilities or to know about what is the land and what is happening in the land. Everything should be known by using this trigonometry. For example, we can consider we want to construct a building at a place. So without knowing the slopability, if we construct a building at a place, then we cannot know or we cannot construct an exact building. So by using these trigonometric functions, we can calculate the slopability and we can find out what is happening in the land or what is going at that place. So without using this trigonometry, without finding the slopability, if we construct a building at a place, then the entire building will be collapsed within few days. So trigonometry is used to construct the buildings too, and it is used by geologists. As we all know that trigonometry is used in finding the depths also. It means nowadays due to the heating of earth, many volcanic eruptions are happening. How they are happening? I think you have the doubt in this type. So the volcanic eruptions or the depth of the volcanic eruptions from where they are causing or from where they are happening, all should known by using these trigonometric functions. So they can know everything by using these trigonometric functions. And coming to earthquakes, earthquakes are happening or occurring in our day-to-day life. We are observing that. So the depth of the earthquake or how much distance the earthquake was occurred is known by using these trigonometric functions. So in geological purpose too, it is used in a various purpose. So trigonometry is used to find or to know about the slopabilities or to construct the buildings or to know about the land, everything by using these trigonometric functions. And it is used in navigation purpose too. If we consider an example from history, an accident happened, that is Titanic ship in the ocean, means the depth of the Titanic ship in the ocean. How it is happened, we don't know. It means the navigators who can analyze the way for the boats, the way for the ships, they can move, they can divert the ways. They can know the obstacles. If there are any obstacle in the ocean, they can know everything, and they can understand about the ocean, and they can move the boats. Without knowing all these things, if they had sent the Titanic ship and there happened an accident. So by using this trigonometry, we can know the obstacle which is happening in the oceans. So navigators used to analyze about these trigonometry. They use this trigonometry to divert the ways if there is any kind of obstacle in the submarines. If there is any kind of obstacle in the submarines, they can divert the way of the ship, and many people are protected in the ship. All these things are happening by using these trigonometric applications. So if we use this trigonometry, then our life will be pure. And it is used in oceanography. So trigonometry is used in oceanography to find the depths of, or to find the exact depth or true depth of the ocean. All these things are known by using these trigonometric functions. Oceans, according to this ocean purpose, they find the depth of the oceans and they can know everything about the oceans. Nowadays people are like to do many adventures in the ocean, like as scuba diving. So by doing this scuba diving, they can prove their talent. So by going to do the scuba diving, if they don't know what is the true depth of the ocean, if they don't know what is happening in the ocean, if they don't know is there any kind of obstacle in the ocean, all these things are known by using this trigonometry. So by knowing all these things, they can do the adventures. And these trigonometry is used in oceanography to extract oil or to extract fuels from the oceans. It means, for example, we can take that we need to fix a machine in the ocean to extract the oil from the ocean or fuels from the ocean. So all these things will be happened by using these trigonometric functions or trigonometric applications. So trigonometry plays an important role to find the heights and distances, or to know to construct an exact building, and to know about the land ability or the slope ability, and to calculate the roofs, slopes, and to navigate, and to astronomy, and to discover new things from the space, and to know about the height of the tides, and to know about latitudes and altitudes of the land. These all things are done by using this trigonometry. So trigonometry plays an important role in our day-to-day life. Now coming to now I will explain you an example how we find or how we apply this trigonometry to find heights and distances. Let us consider an example. A man in a boat sees the top of the lighthouse at an angle of 20 degrees above the horizon. He knows that the lighthouse is 165 feet tall. How far away from the shore is the boat? So by using the trigonometric applications, we can apply this trigonometric application to find the distances. Here they have given a problem, that is a man seated in the boat. So he sat on the boat and the boat is moving towards the lighthouse, and a lighthouse is placed at the bank of the river. So to find the distances between the man in the boat and to the lighthouse, a trigonometric application is used, that is tan theta, and they have given us angle that is 20 degrees, and they have given us the height of the lighthouse, that is 165 feet. Now we need to find out the distance between the man in the boat and the lighthouse. So the distance between the man in the boat and the lighthouse will be calculated by using a trigonometric function, that is tan theta. So by using these trigonometric functions, we can calculate or we can know the distance between the man in the boat and the lighthouse. So we are using a trigonometric function, that is tan theta, as we all know that. As we all know that tan theta is equals to opposite side by adjacent side. They have given us opposite side and they have given us the tan theta or the angle. So we used this angle, that is tan theta means tan 20 degrees, and we are using the height of the lighthouse, that is 165 feet. By using these trigonometric functions, we can find the distances between the man sat in the boat and the lighthouse. So the distance between the man sat in the boat and the lighthouse is 453 feet. By using this trigonometric function, we can calculate the distances or the heights or the depths easily, and we can find the accurate result. So these trigonometric functions are useful to find the distances between the man in the boat and the lighthouse. So this trigonometric function is used to know the heights or to know the distances or to know the depths. Now let us discuss about how we graphing of trigonometric functions. The graphing of trigonometric functions is useful to find how the light waves or the sound waves are moving. So these trigonometric functions or the graphing of these trigonometric functions is very useful to find the light waves or sound waves. Let the graph will be drawn in xy plane, along the x along the horizontal direction and y along the vertical axis. So let me consider a function, that is y equals to f of x. F of x is equals to sin x. Here we are having a variable, that is x. So this x indicates an angle that which is measured in the radians. Now graphing of the sine functions. The graphing of sine functions takes place along x and y planes. So here we are observing a graph. The graph is about sine function. So along x axis we are taking only 2 points, that is -1 and +1, and along x axis we are taking some angles, that is pi by 2, pi, 3 pi by 2 and 2 pi and so on. So all these, by using these angles, we can find the values of this sine. So let me consider an example. If we consider an example, that is in the place of x, if we put 0, it means sine 0, the value of sine 0 is 0. So we can plot the point at here, means 0 comma 0. And now coming to next point, that is if we consider x is equals to 90 degrees, that is sine 90, the value of sine 90 is 1, means +1. So we got the point at here. And now coming to another point, now we can take another point, that is 180, x is equals to 180 degrees. So the value of 180 degrees is 0. The point will be comes towards at here. And we can plot a graph in this manner. So the graph of this sine function is like this, and we should know about the properties of this sine function. So the graph will be drawn between xy planes, and the periodicity of this graph, of the sine graph, is 0 comma 2 pi, means the interval lies between 0 to 2 pi. It means one oscillation or one rotation, one interval will be completed between 0 comma 2 pi. So this sine function indicates such types of graphs. If we increase the value of x, then the value of y also increases, and the graph will be repeated and repeated and repeated. So by using these trigonometric or by using this sine function, by using these values, we can plot the graph of the sine function. So it is used to know about the periodicity and the properties, whether the function is period or not, And what is the function? It means it is odd function or even function. Let I tell you about the properties of this sine function. Now coming to domain of this sine function, all real values. How we can say that all real values are the domain of the sine function? I will give you the explanation. That is, here we are seeing the points such as 0, 0 and pi by 6, 1, 1 by 2 and all these points. So by increasing these values we can get the points in the graph. So these graphs these points indicates has one oscillation. So the period of the sine function is 2 pi. It means one oscillation should be completed between 0, 2 pi. And the periodicity of this graph is 0, 2 pi. Now coming to range. Range means the value lies in between -1, +1. It means along the vertical axis, that is y axis, we get the point at here -1 to +1. So between the range of -1 to +1, we get the points, or we can get the points without or by obtaining this 1 and -1, we cannot get the points. So the range of the sine function is -1 to +1. And coming to whether the function is odd function or even function, we can prove that. It means if we consider a function that is f of -x, it becomes -f of x. As well as sine of -theta, it becomes -sine theta. So the sine function is an odd function. So by getting the minus value, we are saying that this function is an odd function. Coming to x-intercepts and y-intercepts, the x-intercepts of these sine functions are 0, pi, 2 pi and so on, means all integer multiples of pi. All integer multiples of pi are the x-intercepts of this sine function. And coming to y-intercept, only at the point of 0 we are getting the y-intercept. And coming to maximum or minimum points, the minimum point or the maximum point occurs in the graph at 1. That is at here at this position we are getting the +1, means at every point, that is pi by 2 or 3 pi by 2, 5 pi by 2, 7 pi by 2 and so on. If we increase the value like this, we can get the points at 1. And along the minimum value, if we come to the minimum value, we can get the points at -1. That is 3 pi by 2, 7 pi by 2, 9 pi by 2, 11 pi by 2 and so on. If we increase the value of these pi by 2, then we can get the minimum values. So these are the properties of the sine function, what I had taught you or what we had discussed. The domain of the sine function is all real numbers, and the range of the sine function is -1 to +1. And the sine function is an odd function. The period of the sine function is 2 pi, and this sine function is a periodic function. X-intercepts occurs at every integer multiples of pi, and the y-intercept occurs at only one point, that is 0. And the maximum values occurs at 1, occurring at -3 pi by 2, pi by 2, 5 pi by 2, 9 pi by 2 and so on. And the minimum value occurs at y equals to -1, that occurs the points at pi by 2, 3 pi by 2, 7 pi by 2, 11 pi by 2 and so on. So these are the properties of the sine function. And I taught you that, or we have discussed that about the sine function, as well as we consider the graphing of cosine function. Now let us discuss about graphing of the cosine functions. The cosine graph occurs in this manner. It means how we consider the values of x in the sine function. We can consider the values of cos, or we can consider the values of x in the cos function too. And let's take y equals to f of x, that is equals to cos x. So in place of x, if we can substitute the value, or we can substitute the angle, that is 0 degrees, the value of cos 0 is 1. And the point will be, the graph will be plotted at this point. We all know that the graph should be plotted in the x and y planes. So along vertical axis, we are getting a point, that is 1. And next, if we increase the value, to pi by 2, it means 90 degrees. So the value of cos 90 degrees is 0, and whereas the value of sin 90 degrees is 1. So the difference is 90 degrees. Note this point. And if we can increase the value, x is equals to 180 degrees, means the value of cos 180 degrees is minus 1. And if we increase the value to the phase of 90 degrees, then we can get the points. That is, the value of 3 pi by 2 is 0. So the cos graph should be plotted in this manner, and this table indicates has about the points. If we take along x is equals to 0 degrees, we get the point at 1, and the point becomes 0, 1. So by knowing all these points, we can plot the graph in this manner. And now the properties, now we can go through the properties of the cosine functions. The domain of this cosine function is all real numbers. It means at every integer or at every odd multiples of pi by 2, not only pi by 2, at every point which we are taking the points, which we are taking the angles of the x, we can get the points. Has 1, 1 by 2, 1 by root 3, root 3 by 2, all these points are getting in this cosine graph. So at every integer or at every all real numbers are the domain of these cosine functions. Now coming to the range. The range will be lies in between minus 1 to plus 1. So the range of this cosine function is also minus 1 to plus 1. And the range of this cosine function is minus 1 to plus 1. Coming to x-intercepts, y-intercepts, these all the next thing. So we can know whether the graph is odd function or the even function. So to know about whether the graph is odd function or even function, we can consider an example, that is f of x is equals to, if we take f of minus x, then the value becomes f of x. It means if we take cos of minus theta, then the value becomes cos theta. So we got the plus value. If we can give the minus or negative value, we can get a positive value. So this positive value indicates has about the even function, and this is the property, this is an even function. The cos is an even function. And coming to x-intercepts and y-intercepts, the x-intercepts occurs at every odd multiples of pi by 2. The x-intercepts occurs at every odd multiples of pi by 2. And coming to y-intercept, at only one point, that is 1. At the point of 1, we are getting the y-intercepts. And coming to minimum value and maximum value, this graph will tell us about the properties of the cosine functions. So the properties of these cosine functions are: domain of these cosine functions is all real numbers, range of this cosine function is minus 1 to plus 1, it is an even function, the periodicity of these cosine function is 0, 2 pi. We are observing that the periodicity of sine function and cosine function is 0, 2 pi. So both period has the same periodicity, that is 0, 2 pi. And this is the periodic function, and the period of this cosine function is 2 pi. X-intercept occurs at every odd multiple of pi by 2. And the y-intercept occurs at only one position, that is 1. Maximum value occurs at y equals to 1 at every even multiple of pi. At every even multiple of pi, we can get the y-intercepts or the maximum value, that is 1. The 1 will occurs at every even multiples of pi. And coming to minimum value, the minimum value of this cosine function is minus 1. So the minus 1 will occurs at every odd multiples of pi. So we are observing that at every even multiples of pi, we are getting the maximum value, and at every odd multiples of pi, we are getting the minimum value. So the properties of these cosine functions are all these things. So we know the domain, the range, whether the function is even or odd, the period, x-intercepts, y-intercepts, maximum value and minimum value. These all things indicates us about the properties of the cosine function. We can discuss about sinusoidal graph. I think you have a doubt about what is sinusoidal graph. This is a new word. So the phase difference or the difference in between 2 points is 90 degrees. That indicates us the sinusoidal graph. Not only the sine and cosine, at every in any graph, if the phase difference is 90 degrees, then the graph is known as sinusoidal graph. So how we are telling that sinusoidal graph? So we can consider an function that is sin x. If we can see here, that is sin x is equals to cos of x minus pi by 2. It means this indicates the right side value, that is cos of pi by 2 minus x or x minus pi by 2 will tells us it is equals to sin x. How means pi by 2 is an odd multiple. So when the function or when the value is in odd multiple, we should change the function. It means here the function is cos. So the cos function will be changed to sin. Means the cos function is changed to sin. So it occurs as x, means sin x. So pi by 2 minus x will occurs in the first quadrant. You have the grip on, you all know about the whether the function will occurs in which quadrant the function will be positive. So we are following a rule that is all silver teacups, means in the first quadrant all the functions are positive. In the second quadrant only sine and cosecants are the positive, and in the third quadrant tangent and cotangent are the positive. In the fourth quadrant cos and secant are the positive. So this is about the quadrants. So in pi by 2 minus x lies in the first quadrant. So cos or every function is positive in this first quadrant. So we are getting the value sin x is equals to sin x at here. So cos of pi by 2 minus x is also an even function. So this is about the sinusoidal graph. You are familiar about this sinusoidal graph now. So the phase difference is 90 degrees in between two graphs, that is known as sinusoidal graphs. Now we can go through graphing of tangent functions. How we consider the value in sine and cos? We should consider the values in these tangent graphs too. So if we consider the point that tan x is equals to, in the place of x we can consider 0. So the value of tan 0 is 0. It means the tan is equals to sine by cos. So the sine 0, if we can place in the place of x sin x and sin x by cos x. So in the place of x if we can substitute 0, then 0 sin 0 is 0 and by cos 0. Cos 0, the value of cos 0 is 1. So 0 by 1 is nothing but 0. So we can get the value for the tangent, or the tan 0 degrees is 0. So we can get the point at this position. 0, 0 is the point of this along the x and y intercepts. And if we consider, or if we increase the points, or if we increase the angles, we can get the points, so on. So the values will be increased, and the tangent value and the tangent graph is increased towards upwards and again to the downwards. And here an very important property, that is that asymptotes. Do you know what is asymptotes? Asymptote is a tangent that meets the points at the infinity position, or meets the curve at the infinity positions. It means at every integer multiples or at every odd multiples of pi by 2 we are getting an asymptote. That means at the infinity position. At this point we didn't get any point, means at the infinity position we get the point. So we cannot plot a graph in the infinity positions. So we can tell, or we can say this asymptote, this infinity position is known as asymptotes. So this is the graph of tangent function. Let us discuss about the properties of the tangent function. So the domain of this tangent function is all real numbers except at every odd multiples of pi by 2. It means at every odd multiples of pi by 2 we are getting the asymptotes. That we discussed that asymptote is a point or is a curve, is a tangent which occurs an infinity position, which touches the point, which touches the curve at the infinity positions. So asymptotes will be occurs at pi by 2. So the domain of this tangent function is all real numbers except at every odd multiples of pi by 2. And now coming to range of this tangent function. So the range of this tangent function is all real numbers. If we increase the value so on, except the odd multiples of pi by 2. It means at pi by 2, if we leave the pi by 2, next again if we increase the values, then we can plot the graph again. So these graph indicates all real values. So the range of these tangent function is all real numbers. And coming to know about whether the function is odd or even. So if we consider a function that is f of minus x, it becomes minus f of x. Means when we are substituting a negative value in the function, then again if we get the negative value, then the function is said to be odd function. And if we substitute a value, if we substitute a negative value, if we get the resultant has positive value, then the function is said to be even function. So the tangent, if we substitute a negative value in this tangent function, then we can get the negative value. So the tangent function is an odd function. And coming to x-intercepts occurs at pi by 2 and so on, all the real values. And the y-intercept occurs at only one position, that is at the point of 0. And coming to maximum values, maximum value occurs at infinity position, means we cannot tell or we cannot say the maximum value. So these are the properties of the tangent functions. Coming to domain of this tangent function, all real numbers except at every odd multiples or multiples of the pi by 2. So the range of these tangent function is all real numbers. It is an odd function and the function is periodic, and the period of this tangent function is pi. It means in this we have observed that in the cos and sine function we got the periodicity has 0, 2 pi. But in this tangent function we get the point has 0, pi, or we get the periodicity has 0, pi. So the tangent function is a periodic function and the period of this tangent function is pi. In between 0, pi we are completing an interval. So we are completing an oscillation. So again the value will be repeated. If we substitute or if we increase the values more and more, then the values will be increased and we can get we can draw one oscillation, we can get the periodicity in this tangent function to the pi only. And coming to x-intercepts, at every integer multiples of the pi we are getting the x-intercepts. And coming to y-intercept, at only one position, what I taught you or what we have discussed in the graph of the tangent function, that at only y-intercept we are getting the 0 point. And asymptotes will be occurs at every integer or odd multiples of the pi by 2. So at every odd multiples of the pi by 2 we are getting the asymptotes. What I taught you, asymptote is a tangent which touches or which meets the curve at an infinity position. So this is about this tangent function. And we can discuss about graphing of cotangent function. I think you all familiar that cotangent is the reciprocal identity of this tangent function. So this is the graph of the cotangent function, and in this tangent function we observe the infinity positions at every integer multiples of the pi. So at every integer multiples of the pi we are getting the asymptotes. I thought that asymptote is a tangent which meets the curves at the infinity positions. So asymptote will be occurs at the integer multiples of the pi. So this is the graph of the cotangent function, and we are getting the points in this function has in this type. So the graph of this cotangent function, let we observe this graph. Well, we can observe the graph of the cotangent function. Now we can analyze. Now we can determine the properties of this cotangent function. So the properties of this cotangent function is, the domain of the cotangent function is all real numbers except at every integer multiples of the pi. So at every integer multiples of the pi we are getting the infinity points. But in the tangent function we are getting the points has at every integer multiples of pi by 2 we are getting the asymptotes. So where the asymptote will be occurs, that should be removed in this graph. That cannot be plotted in this graph, because at the infinity positions we are getting the points. So the graph of these the domain of this cotangent function is all real numbers except at every integer multiples of pi. So in tangent function, the domain of the tangent function is at all real numbers except the integer multiples of pi by 2. So this is the graph of the cotangent functions. I will tell you the domain of the cotangent function is all real values except integer multiples of pi. And coming to the range, all real numbers or the property, all real numbers are the range of this cotangent function. So the range of this cotangent function is all real numbers. And coming to x-intercepts and y-intercepts, we are getting the x-intercepts at every integer or at every odd multiples of pi by 2, we are getting the x-intercepts. So we are getting the x-intercepts. So at every odd multiples of pi by 2, we are getting the x-intercepts. And the y-intercept will be occurred at only one point, that is infinity. At the infinity positions, we are getting the y-intercepts. Coming to minimum and maximum values, we can observe in this graph. So the properties of the cotangent functions are, domain of the cotangent function is all real numbers except the values or except the integer multiples of the pi, and the range of this cotangent function is all real numbers. And the we should know about whether the function is odd or even function. This is an important thing. Then what we had discussed, that if we can substitute a negative value into the function, we need to get an positive value, then the function will becomes has an even function. When we substitute a negative value, then we can, if the resultant we can get has a negative value, then the function is said to be an odd function. So in this cotangent function, we can consider that cot of minus theta. So it becomes minus cot theta. So this is an odd function. The cotangent function is also an odd function. What we have discussed, that sine, tangent, cotangent, these are all the odd functions. Only one, that is cos, is the even function. We can go through the graphing of cosecant functions. So observe the graph, observe here, this is the graph of the cosecant functions. The cosecant function is the reciprocal identity of the sine function. And coming to the properties, before going to know about the properties, I think it is quite different to observe or to know about the domain, range, x-intercepts, y-intercepts, according to all the functions which we have discussed before, that is sine, cos, tangent, cotangent. In all these graphs we can get the range, domain by observing the graph. But in this cosecant function there is a confusion. I will clear your confusion. That is, here we are, this red line indicates us about the graph of the sine function. So the reciprocal or the inverse function of the sine function is the cosecant function. So the blue color graph indicates us about the cosecant functions. So when we substitute a value, we can get, when we substitute pi by 2 in the place of cosecant, means cosecant 90 degrees, we get the point has 1. But in between minus 1 to plus 1, we cannot get any kinds of point, or we cannot plot the graph. So by using all these functions, by using this cosecant function, or by using this graph, we can analyze the properties of the cosecant function. So this is the graph of the cosecant functions. I give you the properties of the cosecant functions. That is, the domain of this cosecant function is all real numbers except minus 1 to plus 1. In between minus 1 to plus 1, we cannot get any kinds of points. So except minus 1 to plus 1, all real numbers are the properties of this cosecant functions. And coming to range of this cosecant function, all real numbers, but we cannot plot all real numbers, but the asymptote will be occurs in this graph. So removing that asymptotes, we get the range. So the range of these cosecant function is all real numbers except minus 1 to plus 1. But the domain of this cosecant function is all real numbers except at every odd multiple or at every integer multiple of pi. So the domain of this cosecant function is all real numbers except integer multiples of the pi. And the range of this cosecant function is all real numbers except the minus 1 comma plus 1. So it is an odd function, means we are discussed before, that is f of minus x is equals to minus f of x. So when we substitute an negative integer in this cosecant function, then we can get the negative point only. So this cosecant function is also an odd function, and the periodicity of this cosecant function is 0, 2 pi. So in between 0, pi. In between this 0 and pi, we can get a period by removing -1 to +1. So this is the graph of the cosecant function, and you can observe the minimum value and maximum value, and we can go through the graphing of the secant functions. The reciprocal identity of the cos function is the secant function. So this is the graph of the secant function, and the red color line indicates has the cos graph, and the blue graph indicates has the secant graph. So in the cosecant function, we can get the integer, or we can get the asymptotes at every integer multiples of the pi, we can get the asymptotes. But in this secant function, we can get the asymptotes, that is the infinity positions, at every odd multiples of pi by 2. So at every odd multiples of the pi by 2, we are getting the asymptotes. So the domain of this secant function is all real numbers except the integer multiples or the odd multiples of pi by 2, and the range of this secant function is all real numbers except -1 to +1. So in between -1 to +1, we cannot plot the graph, and we have to know whether the function is odd function or even function. So the secant is also an even function because it is a reciprocal identity of cos function. So cos is an even function, as well as secant is also an even function. So the secant is also an even function. And the properties of the secant function, what we have discussed, domain of the secant function is all real numbers except in odd multiples of the pi by 2, and the range of this secant function is all real numbers except -1 to +1, and the properties, we have discussed the properties of the secant function, and so on. So these are about the properties of the sine graph. These all graphs will be used to find or used to know about the waves, how the sound waves and light waves are moved. This is about my topic. I hope you have understood about my topic. I hope you have understood about my topic. My guide teachers or my mentors are Ramesh sir and Vikram sir, Rama madam, and I am heartily thankful to all of them. Before thanking them, I will my heartily thanks to R.S. Praveen Kumar sir, the secretary of this tribal society. My special thank to Praveen Kumar sir for giving this a wonderful opportunity to know about my talent in front of all these members. So apply the trigonometric functions and find the heights and distances easily by using the trigonometric functions. Thanks to everyone. Thanks to one and all.